The graph of f of x equals 8x to the fifth minus 5x to the fourth will have many points of inflection. Okay, so to find the points of inflection, I have to find the second derivative. Okay, so there's my first. There's my second. I'm going to factor out a 60x squared. Okay, so I'm going to have x equals to 0 and x equals to 1 over 10. Okay, so before we say that these are points of inflection, I need to make sure that my second derivative changes signs. So I have 0 and 1 over 10. So I'm checking the second derivative, or this one will be easier to check. So let me check -1, number to the left of 0. So this is always going to be positive. So 10 times -1 is -10. -10 minus 1 is negative. So that's going to be negative. I did number between 0 and 110. So how about 111? Okay. So we're going to have 10 over 11. Okay. And that's going to be smaller than -1. So this is also going to be negative. Okay, so number to the right of 1/10, we're going to do 1. So that's going to be positive. Okay, so how many points of inflection does it have? Only 1. It occurs when x equals 1 over 10. The graph of the function is shown below. Okay, so the original function is shown below. On which of the following intervals is the derivative positive? Okay, that's what that means. And the second derivative positive. So basically what I'm looking to make sure that my original graph is increasing. That's what the first derivative means when it's positive, and concave up, because that's what the second derivative means when it's positive. So it's increasing only between B and A, and it's concave up right here. See how it's going to be concave down? So it's only between B and C. Okay, so see, it's increasing, so it's going up, and it's concave up in these points. Okay, so the function is twice differentiable such that the first derivative is negative, the second derivative is negative, so that means that it's decreasing in concave down. For all real numbers of x, if f1 equals -10 and f2 is -15, which of the following could be a possibility of f of 3? Okay, a graph. Okay, so at x equals to 1, okay, my point is going to be 1, -10. At 2, it's going to be 2, -15. Okay, so since it's negative, it means it's going to be decreasing and it's going to be concave down. So it's not going to be anything above 15. So it can't be 15 and it can't be 14. It has to be decreasing, so it has to be smaller. So these are going to be possibilities. So at f equals 3, if it's -18, okay, See how it's going to be concave up? So it can't be 18. Negative 20. Okay. Again, still concave up. So it has to be at negative 25. Okay, for 24, it says, for what values of x is the graph concave upwards? So to find whether it's concave up, I have to find the second derivative. So my first derivative would be 2x over 2. 2 is a coefficient, so I can just leave it, bring it down. Plus, I'm going to rewrite this as 4x to the negative 1. That's going to be negative 4x to the negative 2. Okay. So that's canceled. The second derivative would be 1 plus 8x to the negative 3. Okay. So we have 1 plus 8x to the third. Set that equal to 0. So at x equals to 0, the second derivative doesn't exist, so that's a possible point of inflection. Okay, so if I cross multiply, I get x to the third equals to negative 8. So x equals to negative 2. Okay, so I'm going to be checking at negative 2 and at 0. So at negative 2, I'm going to check to the left of negative 2, so that's negative 3. And I'm checking the second derivative to see if my second derivative is positive or negative. And I'm looking for upwards. I want my second derivative to be positive. So at negative 3, you know what, let me check this one. I'm going to have 8 to the negative 3. So that's going to be a negative number, but that's going to be smaller than 1. 8 over 27 is smaller than 1. So that's going to be positive. So let me check negative 1. So then we're going to have 8 minus 8. So that's going to be negative. And at 1, so 8 plus 8 is 9. So that's going to be positive. So it's concave upwards when x is less than negative 2 and x is greater than 0 because the second derivative is positive. Okay, 25. The absolute minimum value on the closed interval occurs at, okay, so to find the minimum value, I'm going to find the first derivative. Okay, set it equal to 0 to find the critical points. So we have x equals to 0 and x equals to negative 3. Since I'm looking for absolute minimum and I have endpoints, I'm going to have negative 3 and 0. Okay, so to the left negative 3, I'm checking negative 4. I'm checking to see whether my first derivative is positive or negative. So 6 times negative 4 is negative. Negative 4 plus 3 is negative. So that's going to be a positive. Check negative 1. That's negative and a positive. So that's negative. And then check. That's positive. Okay, so this is my max. This is my local min. So I am just going to check. And since I'm checking negative 5 and 2, remember, since it's the absolute, I have to check the endpoint. Since I'm coming this way, okay, then I'm going increasing. Okay, so 2 is going to be either an absolute max or an absolute min. So I just need to check negative 5 and 0. Okay, so at 0, it's negative 10. At 5, that's going to be 2. So my absolute min occurs when x is negative 5. Okay, the graph below shows the velocity of the particle moving a horizontal line. Okay, so since this is the velocity, I'm looking at the derivative. Use the graph shown how many times does the particle change direction. Okay, so it only changed directions once. Because since it's above the x-axis, that means it's going to the right. And then below the x-axis means that it's going to the left. So it only changes direction once. Okay, okay, so to find if the position of the particle moving at the x-axis at any time t is given by x of t to the third, what is the average velocity of the particle? To find the average velocity, you have to is basically the average derivative. So I'm going to find x of 3 minus x of 0 over 3 minus 0. So I'm going to have 2, 3 over 3. So 27 times 2 be 54. And 3 times 9 is 27. So 9 would be my average velocity. Okay. And 28. Okay, so we're going to be using L'Hopital's rule. Okay, so as you notice, first we have to make sure that it's indeterminate. If we substitute 0, cosine of 0 is 1. 1 minus 1 is 0 over 0. So I can use L'Hopital's rule. So the limit as x goes to 0, okay, the derivative of cosine of 9x would be negative 9 sine of 9x minus 0 all over 2x. Okay, so if I substitute 0, I get 0 over 0 because sine of 0 is 0. So I can use L'Hopital's rule again. So derivative of sine would be 9 times 9, which is 81, cosine of 9x over 2. And cosine of 0 is 1, so I have negative 81 over 2. Okay, so if I substitute 1, I get 1 minus 6 plus 5 over 0. So that's going to give me 0 over 0. So I'm going to use L'Hopital's rule. So I'm going to have 3x squared minus 12x all over 1. So that's going to be 0. And then once again, sine of 0 is 0 over 0. So I'm going to use L'Hopital's rule. I'm going to have 7 cosine of 7x over 1. So that's going to be 7 cosine of 0, which will be 7.